Okay, the next part will be to make the top column here now. That'll be 3/4 inch in diameter, and then I will take it down to 313 thousandths here, and then do again some 1/2 inch 20 threading, single point threading, and that part there will be to attach the tabletop to. That's coming up next. Okay, I'm going to come up 1 inch here and work this here across here. And what that is half of this is going to be threaded, and the other half will be that there flange that we showed on top there. But this is the amount that I can put inside the chuck jaws now. And then I'll machine this from here to here now, down to 313 thousandths to fit inside the bore of this. Almost 313. $312. Okay, here's the workpiece. It's just not quite fitting on yet. So I'm going to go ahead and take this down a little farther, probably with some emery paper. I'll take it down. About 311 now. That took it down pretty good. Let's try the workpiece. Okay, just not quite, and I think the reason why, because I think I might have bored this to the 1/1000th of an inch less on the under reamer, I think. So I have to just take this down a bit further, with some sandpaper and some file, and just get that down another half an hour or so. Yeah, that's what it was. I bored this here with the 5/16, and here's the undersized reamer. It goes in there nicely. So I have to take this down to thousandths below to get that, because this was done with the 5/16, which is 312.5, and I just have to take this down over here a little bit more yet to get about the size of this reamer here. Okay, here's the front of this here. That was around 312. The rest is about 311 back here. Because I had the tailstock center on here, I couldn't get back that far when I was doing the sanding on that there. So now I got this down to about 311 also. So now I can fit this on here, and it'll fit nicely now. Got a nice piston fit. Okay, that works good. So what I'll clean up this shoulder here now and get that square so that this can fit on here and spin properly. Already. That's the shoulder cleaned up. Let's see how this fits on there. Alright, looks good. Okay, I just threw a little bit of that there 3-in-1 oil on here. And that's fitting nice. And it has a nice piston fit. I like that. Okay, so next thing now would be to thread this halfway down, leave about a 1/2 inch here for a flange for the table to sit on, and then from here down 1/2 20 thread again that the table will screw onto. That's fitting real nice. Okay. Okay, these spin nice and free like this here. A little bit of friction fit here, between here and here. This spins nice and free, and that works good that way. But for me, I like doing kind of home shop machining projects is for model making, and I'm thinking what I could do is, instead of having this just work as a fit like this, spinning on here, to model the best I can a ball bearing section that could be dropped on top of here, and then this can ride on top of that. Again, 3 ball bearings, 120 degrees apart. But what I probably would do is I'd make a ring, a cage to put ball bearings in, and I would make a little groove inside here that can drop on here, and then this would just remain flat here, and then make that ride on there. So I'm going to look at what I can do to make this work like a ball bearing, and what I'll be doing is I'll be just modeling a ball bearing situation for this, and it's coming up next. Okay, I'm going to probably be threading this bottom of this here eventually and making a nut for this here to keep that from coming up. So I want to keep the length of this as much as I can right now. So I'm going to be using 3/16 inch diameter ball bearings up here. And so what I'll do is, the first thing to do is I'll take 3/16 of an inch off this bottom, and then I'll be able to make the groove in here and then go from there. That way there I can keep the length on the bottom here where it needs to be by taking some off the top here and then putting that together with the ball bearings. Okay, I want to get into the center of this here with this here bit right here. What I'm doing right now is I'm eyeballing up, that's all. I'm just checking the point of this to the edge of the workpiece here. And I got that lined up as best I can with the magnifying glass. I used magnifying glass, and I got it all lined up to the edge as best I can. I'll turn back now. What I'll do, I'll put a gauge out here, and I'll come in. This is 3/4 of an inch in diameter. I'll just come in between the bore and the outside edge here. I'll have to figure that bore again, which I think is 5/16, and then take the distance halfway in between there, and then I will know where to set that gauge at. Okay, the center between the outside diameter and the inside bore, the center line comes out to be about 109 thousandths. So I'll now move this here over 109 thousandths to hit the center of this here. Okay, I got my gauge set up here, ready to move it 109 thousandths. And that should set me in the center of the bore and the outside diameter of the workpiece. Okay, that's all I need is just a groove in there, just enough to fit the ball bearing in on, just so that it has a tractor ride on. Okay, just a real quick test run here. Just one ball bearing in the track. What I'll do is I'll make the cage now that will hold 3 ball bearings, and it'll keep them all in the proper alignment. But I got the length down here that I want now. Again, I gained that back, and I'll make the cage now for the ball bearings to sit in. Again, it'll be a 3 ball bearing arrangement, and the cage will be probably maybe 1/8 inch wide, maybe a little bit more than that there, with holes drilled in it just to hold the ball bearings in a proper position. But that's going to look pretty good. Okay, while I have the lathe going, before I do any more work on the ball bearing system here, I need to get this here threaded yet. I come up a 1/2 inch here and come down a 1/2 inch and thread that for 1/2 20, so that the tabletop will screw onto it. Since I got the lathe going here, that's what I'll do next. Get this finished out first, and then once I get this finished out, then I can make the ball bearing race in the cage and get everything done for this part here. Again, I can use the base here as a gauge. Okay. Okay, so we got accomplished this evening. We put a groove in here that we can put our ball bearings into. Later on we'll make our ball bearing cage, so we have a ball bearing race. And we did our threading here on this here. So the next thing now I can start working on the ball bearing race. I can make that cage now for the ball bearings, have that part done. I still need to fill in the holes here yet also. I need to also thread on the bottom here to put a nut on there to keep everything together at one piece. So I think before I even do any of that, I'm going to go ahead and thread this here yet too. That'll be the next thing coming up. Okay, now it's time to thread the back side of this here now. That's coming up next. Okay, get this in the lathe here, ready to go. I'm threading this with a die here on the lathe, the 1/4 28 thread. Okay, next I'll make a threaded washer for that to screw onto that, and then I'll put some Loctite on there, and that'll keep it tight. And then I'll also cut this down to about half that size there, so that I'll have there just the washer, threaded washer that'll be showing. That's coming up next. I'll make this threaded washer out of this here piece of steel right here. It looks to be about maybe a 1/2 inch diameter. I'll go ahead and drill and tap that to 1/4 28. That part there is done. During the final assembly, I'll put some Loctite on there and put that on permanently. Right now, I'll just leave that loose right now just so I can take it off and on. Okay, now it's time to make the locking handle for this. I'm probably going to go with a 1032, or the 1032 screw. That gives a lot of nice bearing against the shaft here. And so what I'll do is I'll take this out and drill and tap that for 1032 in the milling machine or the drill press next. To clean up that tapping burr. This screw is just temporary, so I'm going to use aluminum for the handle. Alright. Okay, I'll thread it for about 3/8 of an inch in length of threads, and we'll take this down to a 1032 diameter, and then I'm going to thread that with a die stalk up to there. Okay, the thickness of a 1032 screw, about 1/8. I'm cutting aluminum. And lathe here. I'll get that down to size. Okay, I decided to do a single point thread on the lathe for this here 1032 thread, but instead of doing it under power, I'm just going to use the crank here and thread, since I have a very small area to go through here. It makes it easier to stop in time. Okay, I'm going to use a 1/8 inch part that will go through here for the handle. Okay, I'm drilling for the cross handle now that goes through through this here part here, and to ensure that it's up and down whenever it's tight, I put the workpiece, the actual column, in my vise here. Got that lined up. Got this lined up over here a little bit on the Squaring it up a little bit there, across there. And so now that I'm vertical here, I can just line this up now and get as, I'll just eyeball it up, get as close as I can where I want it lengthwise on the y-axis here, and then line it up on center here, and that way there, whenever I go to drill it, the handle will be vertical with the column in the tight position. If I take my time, I can probably drill this right on the column itself. I can't get a center drill in there because it's too high, and this is in the way here, so I would go directly to a drill bit. But if I take my time here, I might be able to actually drill it while it's tight in the column. And now for the reamer. So far, so good. Okay, a piece of 1/8 inch aluminum stock. Some filing on it now. Okay, I think a little explanation is in order here for the next procedure. Whenever I did these here holes here, I did them so that I can index and locate this on my rotary table so I can cut these here profiles on my milling machine. Now it's time to fill these holes in, and what I'm going to use is I'm going to use aluminum pins, and I'm going to put them in here, probably glue them in with some sort of a super glue or something. And then I'm going to take it on my lathe and I'm going to machine these pins down. But now as I look at the column here, I have this pretty much where I want this at. I want the this area here to be in this here open area right here. So with that in mind, when I machine this down on my lathe, I'm going to stop in this area right here and leave a little bit of an embossment right here. And that embossment will allow this here to tighten down to the same spot here where it's at. If I were to machine this all the way down to the center, I may go down too low, and this may end up turning more towards this direction here, which I don't want. I want to try to keep this area in the open area here. So that's what's coming up next. I'm going to put pins in here, glue them in, and then machine this on my lathe and leave an embossment right here. And that's what's coming up next. Yep, that should do it. Okay, there's the top of it right there. Now remember, on the bottom side, I have to re-drill these just a little bit to make up for the screw heads right here. Either that or grind the screw heads. I'm not sure what I'm going to do yet. but I'll have to do just a little bit of boring out here, just a little bit on the bottom side here, and we'll do that later on. Right now I want to next start working on the ball bearing system now. But here's this here put together now, and we'll see how that lines up again. That's what we want that to line up with that ball span there. I can tighten that in a little tighter and get that to the opening here. Okay, that's a successful machining project there for that part right there. Next up will be the ball bearing system now. That's coming up next.